One of the primary goals of MCUboot is to ensure that only authorized images are run on the target. This is done through the use of cryptographic hash functions and digital signatures. MCUboot can be configured in different ways, and this configuration determines which of these various techniques will be used to secure the images. I will cover a common configuration in this video. If we recall from an earlier video, the layout of the slot, we have defined a region of this area that is protected. This includes the header, the code itself, and possibly a part of the TLV block. All of the information we are describing here will be placed after this in TLV entries. Looking in more detail at a TLV entry, we can see that there is a 16-bit tag value, a 16-bit length, and this is then followed by that many bytes of data. The TLV entries are simply concatenated, allowing multiple entries. Our goal here, then, is to be able to add entries to the TLV that MCUboot can use to ensure that the protected area of the image has not been tampered with. Instead of having to remember the details of this data that is to be protected, it can be helpful to just think of it as a sequence of bytes. The first cryptographic operation that we need to understand is what is known as a secure hash. MCUboot is currently built with SHA-256, but most of these hash functions work in a similar way. The hash function has a couple of properties that make it useful to us. The first is what is known as compression. A hash function takes an arbitrary amount of input and produces a fixed-sized output. Internally, it does this by breaking the output into fixed-sized pieces, 64 bytes for SHA-256, and performing the same operation on that block, combining it with the state of the hash function. The resulting hash output is derived from this mixed state. The other attributes of these hash functions are related, the idea being that the hash function needs to behave as what is known as a one-way function. This means that although it is easy to compute the hash from a given sequence of bytes, it is infeasible to produce a sequence of bytes that give you a given hash. For us, this helps because it means if we use the output of the hash as part of securing the image, an attacker won't be able to come up with a modified image that will produce the same hash. We place the result of the SHA-256 hash in a TLV entry tagged with image TLV SHA-256, which has a tag of hex 10. The length will always be 32 bytes, and the 32 bytes should be the bytes of the output of the hash. MCUboot can be configured to only require a SHA-256 hash. This doesn't provide any security to the image, as an attacker can just as easily modify the hash as the rest of the image, but it can be useful in cases where the intent is to detect corruption of the flash contents. In the next video, we will see how this hash can be used with a digital signature algorithm to help ensure that the image is legitimate.